Welcome to the GED Testing Service webinar on improving students' mathematical problem-solving skills. I'm Bonnie Goonan, and here with me today are Susan Pittman and Amber Williams, and we would like to welcome you to today's session. As in the past, the lowest scores and the passing rate on any GED content area test are in mathematical reasoning. You know, our students really do struggle with math. Sometimes it's due to their lack of conceptual understanding. Instead, they rely on those rules and shortcuts to solve problems. However, you know, there's another factor that we often miss in our mathematical instructional programs, and that's the importance of using effective reading skills. So today's webinar is going to focus on those strategies and resources that can be used in the classroom to enhance our students' reading skills, as well, of course, as mathematical reasoning and problem solving. You know, whether the focus is on quantitative or algebraic reasoning, it is important that our students have effective reading skills. So today during this webinar, we're going to explore some different strategies as well as some graphic organizers that will enhance your students' mathematical problem solving ability. You know, the quote on this slide really says it all when we think of how our students approach math. Often they just give up and they feel that they're unable to do math and that they'll never be able to master the skills that are necessary. However, the reality is that our students need to learn how to persevere when they work with problems. Likewise, as instructors, we need to make sure that we're asking the right questions, as well as modeling processes that show our students the importance of not only persevering, but also to have that success that they need. You know, it's sometimes just too easy for us to jump in and help our students. So, what does reading have to do with math? It has absolutely everything to do with math. I want you to think for a moment about the math word problems that our students encounter on the GED test. You know, if they're going to be successful in solving those problems, they first must be able to read and understand what that problem is asking them. They have to be able to locate that key information and distinguish between the main idea of that math problem and supporting details. You know, that sounds like effective readers anywhere, because our readers need to be effective problem solvers, and they have to modify their reading based on the difficulty of the text, or of course the complexity of the reading in a word problem for math. We also want them to be effective readers when they solve math problems by asking questions before, during, and after reading. And as they're reading those math questions, to monitor their comprehension, to evaluate new information as part of that problem, and to connect that new information with existing ideas they have, and then to organize it in ways that make sense. That's what our students need to do as effective readers, and that is what our students need to do as effective math problem solvers. And, you know, sometimes it really isn't about our students having difficulty with the mathematical operation or processes. They may be able to quite accurately add, multiply, divide, subtract, all of those types of things. Instead, Draper, Smith, Hall, and Seibert, as well as the other experts in mathematical problem solving, talk about that teachers often assume that that is the difficulty. But the truth more likely lies with our students' poor ability to read math textbooks. Susan, you and I have both taught adult ed students math. What do you find are some common experiences that students have in math classrooms?
Well, Bonnie, I think there are a couple of different things that happen. First of all, just those math textbooks, and students sometimes, I think, flash back to things they had in a regular high school program where there was, you know, several-inch thick book. They can be intimidating, and our books within our programs as well. What students are tending to do is they skip past all the words and they look at what computation has been done, but they're missing out on a big part of it because they just don't understand. The other thing that happens in the classroom is that they look to us as the teacher to be that expert. I mean, we're the ones who do all the talking. We're at the center of the classroom, and, you know, we're just going to somehow magically impart this information to them. What students tend to say about learning math is that they learn best if they hear an explanation. Okay, so that comes back to the teacher again. Let the teacher explain. They ask someone, or they're told what to do. None of the things that are in there talk to any of the issues with students and what they do. It's all kind of an external thing that is going to help them learn math as they're going through. So reading in math becomes a truly important part of the process that we haven't given a lot of thought to, because there's some real unique knowledge and there's skills that are taught there. And, you know, when I think about it, Bonnie, I think about the fact that, you know, what the research says is that those math textbooks have more concepts per word, per sentence, and per paragraph than any other text type. You know, we tend to think that, oh, science material or a textbook in social studies, they have so many big ideas. But if you think about how condensed some of that information is, but yet it is so dense with skills and concepts, that's a problem. The other thing that's out there is students are just not as proficient at decoding words and numbers and symbols as they should be. You know, you have one way that you use a word when you're speaking in, you know, about regular everyday life things, and then it's used in a different context in math, and then trying to really determine what those symbols mean is something else entirely. So you have to think about what the writing style is like. You know, it's real concise, it's real compact, and unlike a lot of other texts where, you know, it may say something this way and then it says it a little differently, and so you're hearing stuff multiple times or you're reading it, that doesn't happen here. When our students skip over those explanations, then they're losing a big part of the information that they need. Plus, you know, I guess that's one thing, Bonnie, that I know I've never really thought an awful lot about, but textbooks for math are often written above grade level. So if we have students working in a book that we think appropriate for maybe an upper level ABE student, the words and the concepts and the complexity of the text may be higher than that. So that's a problem as we're going through and working with it. So there are just a number of different things, and underneath it all, what we want to do is not just do strategies to teach students how to learn to read the book, but we want them so they can read to learn from the book itself. We want to give them strategies so that when they approach something in a math text, they understand it and they can use it as they're moving through. They can better comprehend, and then we can go through and make sure that our students are doing the same thing, that they really are understanding what they read. The bottom line comes down to the fact that when students approach something like the GED mathematical reasoning test, there are a lot of word problems, and they have to be able to interpret those problems and extract the evidence, in this case the numbers and the different vocabulary that they need, so they can answer a question. So reading is an essential part of this entire process. But, you know, that reading starts with the language of math. And for many of our students who are out there, that's not necessarily something that they know an awful lot about. There are words that they have, and they have an idea of what those words mean, but not necessarily the full understanding. as I was coming across and taking a look, Bonnie, at some of the research, one of the interesting things that I've found is that, and you think about it, our students are quite literal. And so this particular one popped up. Which one is the, quote, right triangle? Well, if you look to the one on the left, that's what we usually see in textbooks. And sure enough, it points toward the right. But can students recognize that one on the other side has the same properties and that it's a right triangle too? Because students aren't necessarily looking at what does it mean to have a right triangle. What does that mean in terms of the angles themselves? What does that little symbol in the middle that of the triangle itself actually portray for them? What does that tell them? Those are some things that students have difficulty with. So, Bonnie, is there a way that we can work through vocabulary without just giving students, here are the terms, here's the definition, let's have a test on Friday?
There definitely are, and as I look at this slide, Susan, my comment would have been I would have had students who, if I had asked them, is this a right triangle, they would have said which one is the wrong one, because you're so right about literal with our students. But yes, many of us learned math by having that 10 words on Monday, test on Friday, and by the following Monday, we had really forgotten those words because we didn't own them. And we always talk about owning words when we're teaching the reading process, but our students need to own those words when they have reading of math as well. And some of the best ways to make sure that our students own math vocabulary is to really have them not only define the words, but provide such things as definitions in their own words, and then to draw it out. What does it look like? Now, it doesn't have to be a great drawing because many of our students are like me. I really draw poorly. However, if I can see what something looks like, if I can see what a right triangle looks like and draw that right triangle, then it's much easier for me to not only give the characteristics of it, but also to do some type of a personal association. When do I see that figure in my real world situation? When do I use that type of thing? And so this would be an example where if a student needs to understand or define such words as root and zero and factor and solution and x-intercept, it's called oh my, that they not only can write a definition in their own words, but they can draw it. They can provide you that visual, and we know that many of our students really are visual and hands-on learners. And then in this particular one, giving the characteristics or the step-by-step of how they can do it. Now, I'm going to tell you this is very complex, and we may not see all of this on a GED test, but it at least shows us that we can use this process for vocabulary at even the highest of levels. If students can do this, they're more apt to, quote, own the word or phrase. Now, there's another model out there that probably looks very familiar to many of us, and it's called the Freyer model. And again, there's so many different types of maps and webs and other graphic organizers that help our students organize math meanings and concepts. This is just another one. In this type of model, I would teach students to define words by having them either divide a sheet of paper into 4 quadrants or drawing it. And again, the word or symbol goes in the middle. Just like in the former model, we want students to be able to define the word in their own words and then provide those facts or characteristics. Can they determine the difference between a rectangle and a parallelogram? What would those characteristics or facts be? And I really like this one, Susan, because I like the fact that students have to give examples and non-examples. As you were saying before, can I give an example of where I would see a right triangle? And can I give non-examples of what a right triangle is or is not? If my students are able to do this, I know they own the word or symbol. And so here is a word that we often see in our math books. It's the term radical. But what does a radical really mean? Can our students really tell us what that is in their own words? Can they give some facts or characteristics of it? Here this student provided what the positive square root of a number is and how you would put a negative square root. And again, examples and non-examples. You know, my students sometimes when they were looking at a radical, they weren't quite sure how it should look. And let's face it, a radical symbol looks very similar to a division sign. Can they tell the difference, example versus non-example? You know, this really goes far beyond what oftentimes we do in the classroom of here's a word, here's a definition. And that's how we want to approach that whole bit of vocabulary in math. But, you know, we can go that next step and have a little bit of fun with it. Susan and I, when we're doing workshops and when we're working with students, know that students sometimes look at math and go, oh, I have to solve problems again. Well, let's face it, what's fun to do in the classroom are some games. We all love to play games. And so we can use games in the classroom to assess math vocabulary. And we'll share with you that we have provided some games for you in the handout that goes along with this webinar. But this would be one example. I could put students into small groups, or I could have them compete against each other. And you'll notice here that this is an algebra game where students have to match the word to the definition, but we go a step further. Can they match it to an example? Putting more than one thing together. And that's what the fun is about using vocabulary, is being creative in how we have students basically show, do they know how to do it or not? But Susan, I think there's more to really understanding a math problem and reading it closely than just knowing the words. Wouldn't you agree?
Oh, Bonnie, I mean, there is so much. In fact, you know, problem solving, that's across the board. It's not just math where we solve problems or in a classroom where we solve problems. There's so much more to that. But, you know, you have to think that in terms of problem solving, it's really something that we in the classroom as teachers, we have to provide guidance in doing this. We have to work students through. And although this particular little graphic here, it is funny, it's also sad, because at the same time that means that that student really didn't know what was being asked of them with being able to find X. I mean, it was pretty obvious. There it was. So I just circle it and that's it. I don't know what to do and how to work with those different components that are included there. And what we've learned is that the single best way to grow a better brain is to engage in challenging problem solving. And that's what we want to do. We want to enable our students to grow a better brain, to be able to solve problems, to be able to go out in the world and do a number of different things. But in order to do that, they really have to have a lot of tools and a lot of basic concepts that are at their disposal. So we have this new term here that we don't often talk about in adult education, and it's called a heuristic. And what is it and why is it so important? Well, it's a fancy term, that's for sure, but it really comes down to this. It's a thinking strategy. It's something that you can use to find information about a problem and help you figure out what to do when you don't know what to do. And that's where many of our students go back, just as the research said, and they go back to having a teacher or someone else say to them, this is what you need to do. But if I have those thinking strategies, those heuristics, then I can approach a number of different problems and figure out ways to solve them. I think, Bonnie, when we talk about it and when we look at different things, one of the biggest problems that our students have when it comes into problem solving is they don't own, let's go back and use your word from vocabulary, they don't own enough heuristics in problem solving. They have a couple of things that they depend on, a couple of strategies that they use to solve a problem, and beyond that, they're lost. What we as effective problem solvers have is we have this whole myriad of different things that we use. And basically these things fall into 4 different categories. So we can give a representation. Sometimes, and I know I like to do this, I like to make a list. Maybe I can make a list, or I could draw a diagram to do something in trying to solve a problem. Sometimes I have to just make a calculated guess, and if it doesn't work, then I go back and try something different. And in that case, maybe I'm going to look for a pattern, or I'm going to make some suppositions about what's going on. Sometimes I have to work through it. I go through and maybe I'm looking at the answer at the back of the book and I'm trying to figure out, okay, how do you get there as you're trying to solve a problem? Then last but not least, maybe I'm going to change it. Maybe I can say it a little differently. Maybe I can solve a part of it, and once I get that part done, that's going to open up other pieces to me. But the main thing and the main advantage that a strong problem solver has is that they have a whole bunch of these things at their disposal to use. Unfortunately, many of our students tend to think that, there is only one way to solve a problem. And much of that comes from the math textbooks because it shows a problem, it gives an example of how to solve it, and then it moves on to another strategy, to something else. It doesn't say, well, you could solve this problem 3 different ways or 4 different ways, but rather here's a way to solve it. So students kind of get that in their mindset as they're moving through. What we have to do in the classroom is move them away from that. So what Jennifer Cromley said is that explicit instruction matters. And in fact, we have to get in front of that group and we have to walk through the entire process and let students see how we as instructors and effective problem solvers solve problems. We have to solve them out loud. We've got to explain how we're thinking. What is our process? I sometimes think, Bonnie, that our students have this idea that we just magically know the answers. They don't see the internal struggle we do in trying to get there and get to the right solution. Our students need to see that because then it becomes okay for them. We've got to use the language of math itself and make sure our students do. We can't call that less than or greater sign that thingy that shows something. We have to be very specific in what we're doing and the language that we're using. And we use the term model, but, we use it in a number of different ways. Sometimes we model by just solving a problem, but we need to model strategies. How did I decide that I wanted to look for a pattern in a given problem? I need to tell students how I got to that point, what I was looking at. And our students need time to talk. They need to discuss strategies. So much of what we're doing within math problem solving is about helping students build their reasoning skills. And, you and I have talked a lot about the fact that you don't learn reasoning from a book. You learn it from interactions and talking through and disagreeing and trying something different and opening up options. And that's what we have to do. And we clearly, because math seems to be one of those subject areas that students, they kind of go to it like they go to the dentist, I really don't want to do this. we've got to make sure that what we're trying to do within our lessons is actively engage our learners so that that spark can have a chance to be ignited and get students excited about math and what math can do for them in school, taking the test, going on to the workplace, and so forth. I mean, those are the kinds of things we have to look at. Now, there are a number of different things that you can do out there, and one of those really comes back to using graphic organizers. Because for many students, just like the graphic organizer that Bonnie was talking about earlier, that allows students a way to kind of sort things out. What is it that I need? What is it I don't need? It can give me structure. And for many of our students, there is a lot of comfort in that structure itself. But Bonnie, I think as we're looking at this, probably that third bullet is one of the most important, because with a graphic organizer, I can begin to see relationships. And that's a big part of problem solving, is to see the relationship between numbers and among the different components within a problem itself. So one size doesn't fit all when it comes to graphic organizers. In fact, not all students are going to like certain kinds. But I think it's important for us as instructors to open that door to allow students to have opportunities to learn different ways to work with these. So, Bonnie, can you talk a little bit about the value of teaching with problems? I mean, why is it so important?
First of all, of course, research tells us that if we teach problem-solving methods and if we teach mathematical concepts rather than just the algorithms, that students not only have better attention to mathematical ideas, but to me the most important thing is they develop mathematical power. They develop the idea that, you know what, yes, I can do this. I'm capable of doing math because I need to solve problems everywhere in my life. It's not just about math, it's about my daily life. You know, oftentimes we'll say, but I'm not sure I have enough time in the classroom to really teach a good problem-solving method. And Susan and I will say we can't afford not to have the time. But those of the instructors that we've worked with on an ongoing basis have said that really teaching using problems has been the best thing they've done in the math classroom, because not only it supports student learning, but it also provides them with an ongoing assessment system of seeing where do students need more assistance, where have they nailed it, and it really helps students get that entry point. Susan and I would always tell you that we don't want students to, quote, write without planning. Well, we don't want them to solve math problems without planning either. And that's why we need to use not only graphic organizers or some type of organizer to set up the problem, but we need to give them an approach. And I'll be the first one to tell you that there are many different approaches to problem solving as we look at our materials. You know, there's just a myriad of ways that we can teach it. But it all comes back to a real simple process, and it's one that was developed by a gentleman by the name of Polya. George Polya's name should be familiar to most of us. And back in the 50s, he said that an approach to any type of problem solving is you first have to understand that problem. And then after you understand what it is, you need to devise a plan to solve the problem. Then you're going to carry it out, and of course we always want to look back and reflect, did it work or didn't it? If it didn't, we're going to look again at understanding a little closer what we were supposed to do, carrying through the method. You know, as I said, other strategies may include different steps, more steps, but they all seem to be based on the work of Polya. And of course, because there are so many strategies used, we need to make sure that students, as they're using it, remember their heuristics, their problem-solving strategies. And although this is one list, there are different heuristics or problem-solving strategies that students can use. And that's the thing that we want them to do. If we model one type of problem-solving strategy, do students have others? Because there's not one right way. But the other important thing as students are problem-solving is to really support them in understanding that they're going to make mistakes. You know, if Albert Einstein said that he made mistakes, and he's real honest about saying that in his quotes, then our students need to understand that the first time may not make it. Perseverance is so important. So, as Susan talked about, there are a number of strategies, but there's also a number of tools that you can use in the classroom with your students, some of them being graphic organizers. When we teach reading and writing, especially reading, many of us have used the KWL or the KWHL as a reading tool. And students, we ask them, what do they know about a topic, the K? What do they want to learn, the W? And after they're done reading, to summarize what they have learned, the L. Well, you know, we can use that same pattern in math by doing a KNWS graphic organizer. And this particular one came from Heidemann. And the graphic organizer is really quite simple. As students are reading a problem, we want them to identify the facts that they know from the information in the problem. We also want them to identify the information that they do not need. My students always, if there were 5 numbers in the problem, they try to use all 5 numbers to solve the problem. So they need to look critically at that problem and see, is there any information not needed? Then the W, what does the problem want me to find out? Looking at it and saying, okay, what am I supposed to do? And then the S, the strategy or the operations I'll use to solve the problem. If I can teach students to do this, that setup of the problem-solving method, then as an instructor, I know that solving it is going to be much easier. In fact, I would spend time in doing nothing but this with my students, really decoding the problem. So Susan, let's look at how this works in a real-world situation, because I don't know about you, but I always found that if I could take whatever I was teaching in math to real-world situations, things that my students had to do, they were much more willing or eager to learn what we were working on. So let's take a look at how KNWS really would work with a real-world situation.
Well, and Bonnie, we're going to use something that probably people do. I mean, you see all these people going to the little red box outside of the Walgreens where they rent videos, and they do a number of different things there. Well, this particular case, what we're going to do is we're going to talk about a problem where a person has a choice to make. And it really comes down to understanding all those different elements of the problem, just as you said, but we've got to have a way to organize the information. So here we have our problem where we have this video online company and they rent movies. And for $3 every night, you can go get a new movie. But like all good companies that are out there, they've got a special plan. And so for $100 a year, you can get 2 free rentals each month. You can get an unlimited number of rentals at not $3, but $1 per movie each per month. Now, or each per night. Now, the thing that we have to think about here is, okay, I have to figure out how many movies I have to rent to make that club deal worthwhile. Because if I'm not careful, I might just look at this and say, oh, wow, I can get those for $1. I may not be saving money. So now I've got to find out what are my facts, what information is not really needed, and go on from there to see how I'm going to solve this problem. So we filled in the graphic organizer. And basically what you're looking at is this particular one, okay, what do I need to know? Well, I know that there's $3 to rent one movie. I know the cost of the club plan. I know how much a movie costs under that plan. And I've got 2 free movies a month. Now, you know, I can look through this, and in this case, I don't have a number, so to speak, that I'm putting into this N, the stuff I don't need. But I do have that statement about it allows unlimited rentals, because that's really not important to what I'm trying to do. Again, what is that question asking me? Well, I got to figure out how many movies I'd have to rent in a year to make joining the club worthwhile. So, Bonnie, as you said earlier, I could approach this different ways. And under those strategies, I can list a couple of different things, because maybe as I work through one, it's not working the way I want it to. And so I switch over to another one. So I can put my options here. I can make a chart to compare the costs, or, as this problem really is, I could write an inequality. Now, Bonnie, if memory serves me correctly, inequalities is one of those areas where students are having a lot of difficulty at this point. And so it's one of those things now that we could actually work with students on. What would that look like? What would I need to do? But, you know, Bonnie, this is a pretty basic problem. And our students on the GED test are encountering something a little bit more challenging than that. So we can do the same thing with another type of problem. Now, this particular one, for those of you who actually have spent time with either the mathematical reasoning item sampler or the free practice test, you probably recognize good old Hartley and his food truck business. Same process. We're going to use this same strategy, use this same graphic organizer to organize our information from this more complex problem and then go through and figure out how to solve it. So I'm going to collect what I know. I'm going to see what is it I don't need. I'm going to determine one more time, what is it that the question wants me to do? What am I having to do with this? And finally, how could I go about this? And the interesting thing is that although very quickly someone who's reading this problem and has an understanding of some basics in algebra would recognize that it's a slope problem, and the key for that comes back under that K column where it says increase at same rate each day. That tells me that's going to follow that straight line. It's a slope formula. I could go very quickly on the test. I could look at the formula page, and I could use formulas in order to solve it. Or I could sit down and I could draw a map, or a graph, excuse me. I could draw a graph, and I could plot out and see where that graph is going to lead me. Or I could take kind of a really basic, simple approach, which is that I'm going to find the difference between day 2 and 5. I'm going to divide that by 3, see what my increase is each day, and then I'm going to figure out how many more days and multiply. I'm just doing some basic math. Now, multiple steps, but I'm approaching it in a different way. So there's 3 different ways that I could actually go through and solve this particular problem. And I think for students, this would make, when they have these strategies, what this would do is give them a level of comfort in knowing that if something didn't work right on the first go-round, I have an option. I can go and I can use that word you used earlier in this webinar, persevere. I can work through and try and try and try something again. But just as there's this graphic organizer, and in this problem there were multiple ways to solve it, Bonnie, there's a different type of graphic organizer that we could use. So could you talk a little bit about the graphic organizer from Zolman?
Definitely. Many of you may be seeing Zolman's name in lots of research, as well as maybe you've heard him at some of the conferences. As you look at some of the ways your students do things when they come to you, you may have some students who, instead of doing that, hierarchy of step by step, you may see them using a different approach, a more nonlinear layout of a graphic organizer. And this one does come from Zollman. And students who have used this, instead of always going in a step-by-step process for decoding the question, you'll notice that this one provides what we often call 4 corners in a square. And as students start finding the main idea, brainstorming ways to solve it, connecting it to what they know, writing the steps, and then actually solving it, what it does is allow students to think of different units and brainstorm through. So the idea is not needed in short term because, you know, there's this reminder there. So if they think of a possible procedure for their answer, they put it in. If they go and say, oh, but I need this, it may sound a little bit disjunct to you and me, but it's a different way of looking at things. So by using this particular graphic organizer, 4 corners in a square, or oftentimes called 4 corners in a diamond, it encourages students to start working on the problem before they've identified a solution method. They organize their information, they edit their thoughts, and then they go through the write-up. So remember we had good old Hartley. Let's look at how that type of a problem would actually translate to this type of a graphic organizer. Well, students still need to know the main idea, and that question is how much will the business earn on day 10? But they may brainstorm ways to solve it, such as Susan talked about previously. Maybe they see it as a proportion or a ratio. Maybe they talk slope. Maybe they talk rate of change. Not one way to do it, but brainstorming ways. Again, they're connecting the ideas of the problem, and that's what you see in that left-hand corner. They write up, and you'll notice that word relationship. We had talked earlier about the importance of students understanding relationships, and then they solve the problem by setting it up. Again, a different way of looking at the problem-solving method, because not all students are going to solve it the same. The important thing is that they have a process or a structure for problem solving. And as we said, we believe in providing multiple ways. So, Susan, let's look at one more way, because many of our teachers may be familiar with something called SQ3R, which is a reading strategy where students survey, question, read, recite, and review. And here again we have a problem-solving method which takes a reading strategy and expands it. So this particular strategy is SQ, RQ, CQ, where we want students to survey the problem, skim it, and get an idea or the nature of what problem they're supposed to be solving. Question, ask what the problem's about. We want students to ask, what information does this problem require? Or restate that problem in their own words. Then we want them to read carefully. We've talked about close reading in previous webinars. We want them to closely read the problem in math as well. We want them to identify that important information. We want students to identify facts, relationships, details, that important information that they know they need. And then, of course, we want them to be able to question, asking themselves as they read, what operation should I use? What numbers should I use? What order should I use? What strategies may I need to use? What information's there? And is there something not given? Is there something unknown? And, of course, we want them to know what units may I need to use. Then we want students to compute or construct. This is where students would complete the computation to solve the problem, or the question may be asking that they construct a solution. Maybe they need to draw a diagram or make a table, or we know sometimes on the GED test they don't have to, quote, solve the problem, but they need to set up the problem. Then, of course, we want them to question. Is the algebra or the calculations correct? Does the solution make sense? Have I used the correct unit? When you look at this, it really can become a nice table that students, as they're problem solving, that they put their answers or their ideas into the table. So there again, let's take a look at how we apply this type of a graphic organizer. And as you've seen throughout this webinar, Susan and I really believe that as you're teaching a new strategy or a new organizer, you need to start easy, because what we want students to do is focus on the process. Once they've learned the process, once the process has become their own, then slowly but surely we problem solve with more complex or more difficult problems. But by that point, they know how to use the organizer. Susan, we've got M&Ms here. Gosh, I can think of many ways to use M&Ms in a problem, because I have something that I could even provide a hands-on, which would be lots of fun. Don't you think?
I think so, because if the end of the thing, you could actually eat the evidence and go through and enjoy as you're working with this. But you know, in this particular case, I think what this problem highlights more than anything else for students is that there truly are some very clear-cut relationships within this problem. Because as I'm looking at this, Bonnie, I see that, okay, I have twice as many red as blue. So there's a relationship between the number of red M&Ms and blue M&Ms. And then there are 5 times as many blue as yellow. So right off the bat, I should start thinking about how this is going to impact me as I go through and start working with this particular problem.
I think you just confused me, Susan, by that problem. So can you make it clearer?
Well, that's what we're going to do here. Okay, so let's take a look at it and see. First of all, we know, because we've surveyed the problem, we know we got a certain problem that we're going to be looking at. We know we have 3 colors, and we know there are conditions that are placed on those 96 M&Ms. So it's not just like we can go and say, oh, 3 into 96, and boom, 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 we're done. It's different than that. So what is the question really wanting us to do? Well, it wants us to say how many of each color is actually there. So now we go back and we say, okay, I've got to look at what my relationships are and what is the facts. So the fact of the one of the facts of the problem is that we know red plus blue plus yellow equals 96. Pretty straightforward. Now we look at the relationships. Red equals 2 times the number of blue. Okay, so we know there is a relationship between red M&Ms and the blue M&Ms. Now there's another relationship, and that one is that the blue is 5 times the number of yellow. So we have a relationship there. So what can we do? Well, we could write an equation, because we know R plus B plus Y equals 96. Or maybe I'm a little uncomfortable with going the equation route. Maybe I want to make a table and I'm going to try some numbers. So I'm kind of combining 2 heuristics here. I'm doing a little checking and revising, and I'm also using a very structured format to do that, a table itself. And I'll see how I can get these different pieces to work. So now I go through and go, okay, well, I'm going to dive right in and see if I can construct that answer based on what I said was my equation. So go back to my relationships. I know red equals 2 blue, 2 times blue. Okay, so I can substitute my R with a 2B. I know that B is equal to 5Y. Because remember, back up there where I was looking at relationships, that blue is 5 times the number of yellow. Okay, so now I've got that. So I can go through, and now I'm going to go out and I'm going to start changing out and substituting in. So now, okay, there's red and blue has a relationship, but also blue and yellow, so I can go in and substitute my B for 5y. Now I'm sitting there with all these y's. 10y plus 5y plus y equals what? 16. But I have to find out what 1y is. So I do my division, 16 divided on both sides, because I got to maintain that equality there. I got to keep them equivalent on each side, and I find out that y is 6. So now I can go back in and say, okay, I found my yellow is 6. My blue, we know that's 5 times the number of yellow, so B would be 30. And now we know that red is 2 times the number of blue, so we have 60 for the red. 6, 30, and 60. It wasn't a simple process, and it took time to work through it. But what did I have to do within this? I had to use my reasoning skills to see my relationships and also to work through those. Now, I could go back, and if I want to check my work and make sure that somewhere I didn't go off the wrong way, I could use that table, and I could insert those numbers and see if it works. Again, it was not a simple process going through, but the positives of this is it kept asking me to ask questions and to answer those questions in a logical format moving through. I think, Bonnie, that's one of the things I like most about this one, is that students are constantly questioning. And that's what we want them to do if they're going to be effective problem solvers. So
Susan,
hopefully that makes...
I was going to say, I need to ask you, though, would you teach all of those steps in one lesson?
Bonnie, no, I wouldn't.
Oh, okay.
In fact, what I would do is I would break it down so that I'm just taking a couple of different problems, and we're going to survey and question. I'm going to do my first 2 steps and get students comfortable with that. Then I could go back in and I could use those later and have them, okay, let's revisit this problem, and now let's start picking up the R and the next Q. So I would teach this in a progression as I'm moving through. I want students, if they're going to use something like this, to be very comfortable with it, just as I want students with KNWS to be comfortable with that, or with Zolman's 4 corners and a diamond. Anything that we're going to do in this way needs to be introduced over a period of time. Now, I'm not saying you have to do this for weeks and weeks on end, but it's not something that I would throw at students and say, we're going to do this entire thing today. We're going to take parts of it, make sure students are comfortable, that they can consistently get the correct responses, and then we'll begin to build on it. So, Bonnie, I guess the answer to that is we're scaffolding. We're building on information as we go through, and as a result, building some skills.
You know, and as I look at this process, I think I could use it in the areas of both quantitative reasoning and algebraic reasoning. I can't think of a problem that would not work with and help my students really understand what that problem is asking.
I think you're right in terms of being able to use it in a lot of different ways, but I also know that for some students that might be just a little bit overwhelming, and so depending on my students, I'm going to look at a number of different things, and you know as well as I do, there are so many different strategies that are out there. You know, you have the STAR strategy, you have solve, you have cubes, all of these things. And so maybe, you know, the one thing that I would say as an instructor is I've got to be flexible in how I work with this. I've got to understand that one size isn't going to fit every student, and that some students are going to be more comfortable in certain areas than others. And it's my job to figure out what works best for them. this may work best for me, but that doesn't mean that it's going to work best for them. So I have to have my options, and I think that's where just having some different resources available can make a difference for us as we're going through. So, you know, Bonnie, the thing is that what we have to do is that, you know, it's time for us as instructors to kind of think back and say, okay, I need to think about this a little bit. What am I doing right now and that I find is really effective with students? And are those strategies working for them as they get into more and more complex problems? Because the bigger concern really comes into those higher order reasoning strategies. So am I doing stuff now that works at the lower levels, but it's not doing as well in the others? So how am I going to put some changes in there? What strategies can I implement? If I'm working in a classroom where a lot of my students are working, quote, independently, can I do more group instruction, small groups, getting them together so they have an opportunity to talk and interact with each other? Those are some of the things that, as an instructor, I've got to figure out why it is that our students are still struggling with math, and what is it that I can do to make that transition over. So, you know, there's a couple of challenges I think that are out there, and you and I have talked about this a lot, is that we do need to focus a lot more on problem solving. We have to get into algebraic thinking. It's not just something that's at the back of the book, and we'll get to it if we get to it, but it's an essential skill not just for the GD test, but for someone who wants to go on into higher ed. It's going to make a world of difference if they have that strong foundation. The other thing is I've got to figure out a way when, especially, I'm not a math instructor. I don't have a math degree. I like math, just as you like math. I like it. But I'm a social studies at heart, and I'm a history major. And so it's very easy for me to just kind of fall into the trap of let me teach some rules and processes and shortcuts because I understand how to do those, but I may not always have the greatest understanding of that deeper understanding of why those things work. So that shift for me seems to be one that's probably going to be one of the more challenging as we go through and we try to think of how do we deepen our students' math skills. We're going to have to figure out how we deepen our own understanding of math as we go through. And also, you know, that if I do happen to be one of those math majors, that I'm going to have to teach some close reading strategies in the classroom and when I'm teaching math, because I can't just depend on that to happen in some other class or in some other session. Those are things that, as an instructor, I need to start thinking through and reflecting on it. But there's one thing I don't have to start new. It's that, and Bonnie, you and I have had so many talks about the fact that our students can do really great things. They can learn the math that's here. They can gain those algebraic reasoning skills. We know that. We just, as the instructors, have to figure out how we help them achieve it, because as long as we have those high expectations for students, then our students will live up to those expectations. But, Bonnie, I think there's one other thing, or maybe a couple of other things we need to talk about before we close out for this webinar. And one of them is about going in the direction of real world. I mean, people think, how am I ever going to use this when it comes to algebra? So can you talk just a little bit, a minute or two about the resources that are out there and maybe where we need to shift in terms of instruction?
You know, I think even with the best teaching strategies available, sometimes our students are still going to say, why in the world do I need to know this? I am never going to use this. And you're right. We need to make sure that as we're teaching these big ideas of math as we're teaching the strategies that we always connect them to real-world situations. And when you look at this particular problem that we have up here, the first thing that my students would have said is, if you're telling me this is algebraic reasoning, where's the X? Where's the Y? Well, it isn't always there. And yet all of us use algebraic reasoning every day. When we have to determine, how long it's going to take us to get to work and what's the last possible minute that I can, have my coffee in the morning before I need to go. So being able to access real-world situations, such as this particular problem, is an excellent way to not only teach problem solving, but to show students how they're going to use this type of math in their real-world situations. It's also something that I would definitely look for when I look at materials. Are there real-world examples? Are there real-world problems for students to solve? And just as importantly, as we're teaching different concepts, can our students tell us how they could use that process, how they could use that concept in their real-world situations? It may take a little bit of time to do that, but it connects students so that instead of just learning something for the day or for the test, they connect and they're able to apply it on an ongoing basis. And that really says to all of us that we need to move instruction in math from that just cursory approach. I introduce a skill, and of course Pythagorean always comes to mind, where I teach a formula. My students have no clue why that formula works. They may not even have a clue of how they could use it. But there again, it needs to move from just teaching the formula, having our students complete a few problems, and then moving to that next skill. That's a cursory approach. Instead, we need to teach via concepts, where our students get to use that step-by-step to organize new knowledge. And as we're conceptually teaching any idea, that we develop units around those big ideas, those big concepts. And again, we always check for student prior knowledge. Is there something that they can bring to the table so that when we're teaching, it connects? It really is about the whys and how we can use it, not the what of a step-by-step process. Although step-by-step is important, if we want students to connect, if we want them to be able to apply or use that information in different situations, they really need to learn the why it works and how it's going to connect. When we say here that it's not about worksheets, drill, and memorization of discrete facts, please don't hear us say that there's not a place for skill and drill. Yes, there is. But first, students need to understand those big ideas, that conceptual knowledge, and use worksheets or drills to, again, hone those skills once they know the concept. So just providing our students with worksheets or drill isn't enough towards conceptual understanding. I know that for me, if I don't understand something, doing something the wrong way many times is not going to build my knowledge. And so as we look towards conceptual teaching, the first thing that always comes to mind is, okay, where are the resources? How can I as the instructor get more information so I can implement some of these things? And so Susan and I are going to share just a few things. First of all, a little bit of information from the guide that went along with this webinar so that you can see the types of materials that are there. And then we'll talk briefly about what does GED Testing Service on their website have that will assist us in becoming more effective math instructors. First of all, Susan has pulled up here the guide that we have developed for use with this webinar. So let's take just a quick look at what's here for you to use in your classroom. The first thing is some helpful problem-solving heuristics. And this research is provided to you from a resource, and although the resource is somewhat dated, the heuristics are not. Good math-solving problems, processes have not changed over time. So you have a list of some heuristics. You also have the copies of the materials that we use today. So if you go back and say, what did Susan and Bonnie say about KNWS? You have that information here in your guide, along with some templates for you to use in the classroom. The same thing with SQRQCQ. You have not only that process for the sample problem that we solved today, but also you have a template for that. As you look at the resources, we talked about different types of templates for vocabulary. You have copies of those as well to use. And what we hope is that you find these templates useful as you go back to the classroom and think about, how do I start teaching problem solving? On page 17, you'll notice that you have some templates for different problem solving graphic organizers. Although we didn't go through those today, we did note those on one of the slides, and you may remember seeing those, such as the solve strategy. Again, just different ways of problem solving, because one way doesn't work for everyone. Susan and I often found that as we were teaching the problem-solving method, or we were decoding math problems with students, the first thing they did as they were decoding was to say to us, "Teacher, can you help? What is this problem asking me to do?" Just like in reading, where students need to decode words, in math, students need to decode what the words are telling them to do. And we found that a math translation guide was extremely useful, where if students saw the symbols of math, they could see, what does that translation mean? Not only seeing, quote, the English version of it, but also some examples of how it works. And we provided you with a couple of examples. It was just about, 2 months ago when one of our fellow instructors said, "You know what, I took that translation guide back to the classroom and showed students how it worked," and he said it was amazing that all of a sudden they started having fun decoding and seeing who could decode best. So these are strategies that take a little bit of time, but really do work. The other thing is, Susan and I, we wish when we first started teaching that we had as many resources as all of us have now. The World Wide Web is absolutely amazing. Susan, are there a few here that you find to be your favorite?
Well, there are a couple of things, and the first one, and I know it's a personal favorite because I keep going back to it myself, is the Annenberg Learner. And the reason for that is, just as most people who know us out there know, that you and I are baby boomers. So it's been a while since we've been sitting in an algebra class or a geometry class, and so some of that information, I just need a little brush up on it.
Are they doing algebraic reasoning now to figure out how old we are?
Well, I think they could probably come up with a pretty interesting problem for that. But having said that, though, what is interesting is that going into Annenberg Learner, what you and I have both been able to do, because we both use the site, is go back and kind of refresh on some of those underlying whys. Why does this work, and how does this work, and not just a bunch of, shortcuts and rules, those types of things. All the resources there are free. If you want to earn college credit, then you can certainly go through, and there's a fee that you can pay in order to do that. But for use within the classroom and for your own professional development, it is a wonderful site. Another one that I like is the Math Dude. I mean, I got to admit, the guy, the teacher who does this, he is a wonderful person to learn just different concepts in a very real-world situation. And so it's a whole video collection developed by Public Broadcasting through Montgomery Schools, Maryland. And it covers, I can't think of anything, Bonnie, that's in that list of videos that we don't see on the GD test. And
so true.
It would be such a great way to work through the entire thing. The other thing that I really take a look at, too, is I like PBS Teacher Source. I think they have some wonderful things that are there. And also, that National Library of Virtual Manipulatives is great because so many of our students, if they're going to get that foundational, that conceptual understanding of different math concepts, they need some hands-on. And maybe they can't hold a little algebra tile in their hand, but they can certainly move one around on the screen. So that's a great resource as well. And then the other thing is just kind of a reminder, because I know that we've talked to people before on webinars about this, but you know, if they need in the classroom a guide for the TI-30XS multi-view calculator, there is one available on the Texas Instruments site. But even more than that, the wonderful thing is that they have lesson plans that have already been developed. And I would just encourage people to go out and take a look at those resources, because sometimes our books don't cover everything that we need. And so where can we go that we have high quality material in a website that stays very stable and not changing around to different things? But I think that's the main thing, is to go out and actually spend some time there. And then, of course, we have all of the different things that we can go into with the GED testing service and looking at Twitter and Facebook and the YouTube channel itself. All of those things could be very important for students as they're going through.
And Susan, we can't forget the National Council for Teachers of Math and the Adult Numeracy Network as well, because, again, that's our professional resources which give us great math information.
Absolutely. I mean, those are wonderful. And then sometimes, you know, there's another thing here that we have included, and you talked about it just a little while ago, but how important it is to use games. You know, get students engaged, get them really understanding it and having fun with math as they're going through. So at the very back of this little resource guide, you'll find a matching game that you can use for algebra. So take advantage of that as you're going through. Now, one other thing, Bonnie, and that comes back to something, a resource that the GED Testing Service has put together, and that's the performance level descriptors for mathematics. They're available in all 4 content areas, but at the same time, we really need to take a look at what all is included in those performance level descriptors so that we can begin as professionals to assess where do we have some gaps in what we're doing and where are we in terms of helping students get to that passing level, but beyond that, passing with honors, because that can make such a huge difference as we're going through. So all in all, there are so many resources and materials that are out there, and it's just a matter at this point of being able to go back in and see where can I begin to make small changes and then bigger changes in the classroom, because ultimately the bottom line is we want students to be doing much better in math. They can do better. We've just got to figure out how to tap into all of that potential that's there. So having said that, Bonnie, any final words before we close out this webinar?
I think that as we go forward, what you and I have found with working with teachers, students, it really is about problem solving, and an integral part of problem solving really is being able to closely read and determine what needs to be done. So on behalf of GED Testing Service, Amber, Susan, and myself, we would like to thank you very much for being with us, and tune in next time for another topic.